Please take notes as we go through the videos. Pause the video if you need more time to write information down. Before we get into how binary code works, we need to talk about memory. Memory is processed in a bit. A bit is what a computer runs on. It is electricity, like an on and off switch. It is represented in zeros and ones. Those zeros and ones are often what you see if you look up the background of computer communication. Something like that. Just a bunch of zeros and ones and ones and ones and zeros and zeros and zeros. So where does the characters come from? How do we know what a computer is saying? And that's what we're going to get to. Before we get there, we need to talk about how many bits are in a byte and how many bytes equal a character. Now, there are 8 bits in 1 byte. 1 byte equals 1 character. That character can be uppercase letters, lowercase letters, numbers, symbols, etc. In a bunch of code, every 8 bits is a character. So 1, 2, 3, 4, 5, 6, 7, 8. This would be 1 character. Now that we talked about memory, we can now talk about how to decipher binary code. When we think about how we decipher numbers, we think about decimal places, which is base 10. In binary, it goes by base 2. If you recognize the table down here, this is a decimal table for each place for the decimal. So in the ones place, we're going to have a 1. If we are in base 2, what would the next slot be? You're going to multiply by 2. 2. What's 2 times 2? 4. 4 times 2? 8. 8 times 2? 16. 16 times 2? 32. 32 times 2? 64. And 64 times 2? 128. So we now have our place values set out for our 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits of binary code. Before we can use a decimal table, we need to take a look at the ASCII sheet that your teacher should have provided you. This is what you'll use to help you figure out the characters after we decipher the code. When we decipher code, we usually get a decimal. On this table, decimal is stated code, so don't get confused. Okay? So we use a decimal to help us figure out the binary and to find the character. To begin the first process of deciphering binary, we are going to start from knowing a character to finding what it means in binary. So, I gave you the money symbol. If you look at the ASCII sheet and find the money symbol, you need to find what the decimal is. The decimal is 36. So we are going to write 36 down in the corner. Now, to figure out the 8 bits of binary code, we need to start from left to right. Can 128 be subtracted from 36 with giving us a positive number? No, it cannot. So we put a 0. Can 36 be subtracted by 64? No, it cannot. Can 36 be subtracted by 32? Yes, it can. So we put a 1. How much do we have left over? 4. Now, instead of looking at 36, we are going to look at 4. Can 16 be subtracted by 4? Or 4 be subtracted by 16? Sorry. No, it cannot. Can 4 minus 8 be a positive number? No. What about 4 minus 4? Yes, we get 0. So we put a 1. What about 2? Nope. Same goes for 1. So, in binary, the dollar symbol equals 0, 0, 1, 0, 0, 1, 0, 0. Pretty simple. Now let's try finding lowercase I on our ASCII sheet. Can someone tell me what the lowercase I decimal is? That is correct. 105. So off on the corner, we're going to write 105. Now we go through the same process. We're going to look at 128. Is 128 bigger than 105? Yes. So we're going to put a 0. Is 64 bigger than 105? No. So we are going to subtract it. Can someone tell me what that is? $41 is correct. So now remember, we are going to look at 41 and not 105. Oh, forgot to put a 1 here. Okay, does 32 go into 41? Yes, it does. So we're going to subtract it again. 41 minus 32 is 9. 3 for 1 there. Okay, is 16 bigger than 9? Yes. So we're going to put a 0. Is 8 bigger than 9? Nope. So we're going to subtract it. We get 1. Is 4 bigger than 1? Yes. Put a 0. Is 2 bigger than 1? Yes. Put a 0. Is 1 bigger than 1? Nope. It's equal. So you'll notice that we always want to get down to a 0, and you always will. If you get to a 0, that means you completed the decimal correctly. So, for I, that binary code is 0, 1, 1, 0, 1, 0, 0, 1. That is how you convert a character to binary code. Now that you learned how to find a character, look up the decimal, and convert that decimal into binary, we are going to reverse the process. In order to do this, I gave you a set of binary code up at the top. You want to plug in the binary code into the table. So, for the first one, we have a 0, 0, 0, 1, 1, 1, 0, 0. Now this process is very simple. For every 1 place value, you add those together. The zeros you do not. So for instance, we do not have a 1 in 128 or 64, but we do have one in 32. So I'm going to write 32 off on the side. Same for 16 and 8. None for 4, none for 2, and none for 1. So you want to add those numbers together. So instead of subtracting like last time, we are adding. If you add those numbers together, you get 56. Now, take a look at the ASCII sheet. Go find the decimal 56. If you look, it's right here. The character for 56 is then the letter 8. So this code on the left represents the number 8. Now let's take a look at the next one. Again, plug in the numbers 0, 1, 0, 1, 1, 0, 0, 1. We do not have a 128. We do have a 64. We do not have a 32. We have a 16. We have an 8. And we have a 1. If you add them together, you should get 89. Going back to our ASCII sheet, go find 89 right here, and you'll notice that it stands for the character capital Y. So this binary code stands for capital Y. Very simple compared to the last one. Now that you have learned how to convert character to binary and binary to character, it's your turn to do some practice. On the sheet, you have summer, and you need to convert it to a binary code. The next one, I gave you a set of codes that you need to find out what the word is. Good luck. I hope you all were able to do the practice examples. If you have any trouble still, go ahead and rewatch my video, or you can always ask a friend. Thank you for watching, and I hope you enjoyed Binary Code.